We have a rational function here. We are going to want to look at the vertical asymptotes, horizontal asymptotes, x and y intercepts. This one, there's some factoring we can do. I'm going to want both versions of this equation. So I am going to factor top and bottom as kind of a first step. Top factors into x minus 2, x plus 1. The denominator, I can pull out the common factor of x, x minus 3. Vertical asymptotes are the places the graph cannot go. So any place where I might divide by 0, I can't have the graph going there. So I'll look at the denominator and determine the zeros of the denominator. They are 0 when x equals 0 or when x equals 3. I want to point out, I'm going to write the equation of the asymptote as a line. So you do want to say x equals 0 and x equals 3. You don't want to just say 0 and 3. You want to say the x equals to say to the person grading your paper, I know it's a vertical line through 0 and I know it's a vertical line through 3. That's going to break my grid into 3 regions. Each region will have to be filled in with graph. But we need more guidelines. So we'll move on to that horizontal asymptote. The horizontal asymptote is what happens as x gets very, very big. And for very, very big x's, this takes over on the top. And for very, very big x's, this takes over on the bottom. So I can determine the horizontal asymptote by considering what happens when I look at one lead term over the other. This simplifies. And in fact, it simplifies down to just plain old 1. So that means as x gets huge, this entire function, which behaves basically like this function, becomes y equals 1. And I'm going to write y equals 1 because I want to make sure I know it's the equation of a line. So y equals 1 is this line, but pretend like I actually drew it on 1 like I was supposed to. X-intercepts are where the y value is 0. Y is equal to this fraction. This fraction is 0 whenever its numerator is 0. Therefore, my x-intercepts will be whatever makes this 0. That happens when x equals 2. I'm going to look here. When x equals 2, the numerator is 0, and when x equals negative 1, the numerator is 0. So you can just say negative 1 and 2 for this. You don't need to write ordered pairs. But if you were to, it would look like this. When you say x-intercept, it's implied that the y value is 0, so you don't need to write that. For the y-intercept, that's going to be anywhere on the y-axis. Hopefully there aren't any there, because that's a vertical asymptote. But if I want to be sure, if I'm on the y-axis, that means x is 0. If I plug in 0 for x, I get I have a problem. If I plug in 0 for x, I end up dividing by 0. I can't do that. I can't plug in 0 for x. So there's not going to be a y-intercept. So what I have is a grid broken into 3 separate regions based off those vertical asymptotes. In each section, I need to draw some graph. When I draw the graph, it needs to go through any intercepts that I've drawn. It needs to veer away from the vertical asymptote, so veer up or veer down. And as I go further away, as I go far out, it needs to approach this asymptote and this asymptote, but only as I go far away. So in this portion of graph, I know I've got to approach this line, because that's going to go far away from 0. I am going to have to hit this point, because that's an x-intercept. So my graph's going to go like this for sure. And then it's going to continue trending down. In the middle portion, I know I've got to hit this point, but I don't know what's going to happen between here and here. It's kind of hard to tell. So one thing to recognize is that this asymptote of 0 came from this factor, which has an odd multiplicity, which means since the graph is down on this side, it will be up on that side. But if you don't like that, you can take a number like 1 or like a half, plug it into this function and see what the y value actually is, and plot that point. I don't have a calculator handy, so I'm not going to do that. But you'll find that if you plug in 1, it's somewhere above here. So it's going to be like that. So then if I go from this up arrow to this point here, well, as I approach this line, it's going to keep going the same way. So it's going to look like that. Now this third region, I don't have any clues to help me. There's no points to guide me whatsoever. I do know that as I go far away from 0, I've got to hit this horizontal asymptote. And I do know that as I approach the vertical asymptote, I've either got to veer up or veer down, right? And I can't really veer down, because if I veer down, I'm crossing the x-axis. And there's no x-intercept, so I can't do that. So it's going to have to look something like this. And I'm comforted by the fact that the factor that made this vertical asymptote, this x minus 3 that created this, has an odd multiplicity, and on one side it's down and one side it's up. That makes me very happy. This seems very reasonable. If it seems like too much in the weeds to you, you can pick a number like 8 or 7 or 9, plug it into this function, you'll get a weird y value, plot that point, and you'll see it somewhere above 1. It's really up to you. Good luck.